Hello everyone, this is a dimension reduction analysis on option markets and endowments analysis.
In our project, we did part A and part C. For the part A, we first dealt with the AAPL sample data of call options. When looking at the sample data, we found that there are a lot of missing values in this dataset. Then we found that those data were missing was because that the strike of those contracts were too high, that no one bought those contracts. In that case, we think replacing those data with zeros is a good way to deal with it. Then we normalize the data and exist different dimension reduction functions on this dataset. In option markets, implied volatility is a crucial index for predicting the market trends. To get a clear result of dimension reduction result, we set implied volatility as labels to draw the plots. Here are the 6 plots of our result. We can see that the results of PCA and SPCA are quite similar. Although PCA performs slightly better than sample data on SPCA, it can separate the data with low IV from other data. There are some interesting results of TSNE and KPCA reduction. Disney performed really well on two-dimensional space data. It separates the data really well than KPCA. However, when in the three-dimensional data, Disney produced a chaotic new data, while KPCA is really stable and separates the data well and looks like a butterfly. And we can see the result of LLE and the ISOMAP. LLE did pretty well on the sample data. It shows a trend of data by implied volatility. However, ISOMAP performs not so well on those data. We can see that KPCA and TSNE perform better on dimension reduction on sample data, but TSNE is not so stable than KPCA.
Then we apply six dimension reduction methods to the option dataset. There are call and put, two types of options in this dataset. First, we set type variable as a binary target and implement dimension reduction to the whole dataset. We found that these six methods did not perform well for detecting types of options. We then separated the dataset by types of option. We set implied volatility into five categories as target. After applying different dimension reduction methods, we found that Disney and local linear embedding had good performance at identifying options by different implied volatility. Lastly, we use new data from dimension reduction to implement machine learning methods including gradient boosting, random forest, and support vector machine to predict implied volatility. From the result, we found that PCA random forest regressor has the highest accuracy and lowest mean square error. Besides, regressor from original data has the best performance because it explains raw data 100%. However, new regressors are still meaningful when we have too many variables in other datasets.
Let's move on to the endowment analysis. The two tables are the bylaws for PCA. Left one uses the data with initial name. Right one uses the data with Twitter name. Positive value means that the variable has positive contribution to the PC. We can see that private school has larger PC1 value, which indicates that private school has higher GPA endowment, graduation rate, SAT score, and tuition. Variable contributions are similar in the two tables, except for the Twitter followers. Twitter follower has little contribution to PC1, but big contribution to PC2. Then calculate distances between two dots in the PCA biplots and find the five nearest neighbors of Fordham, MSU, Yale, and Smith. In the biplots for SPCA, GPA has no contribution to PC1, and the public or private has no contribution to PC2 in the left table. Outlier, UT Austin has high value in x-axis, which means UT Austin has high enrollment, low graduation rate, and very low tuition. For the five nearest neighbors, except the University of Michigan, other schools have almost same five nearest neighbors. We can see in the biplots for Disney, public and private schools are divided into two clusters. Public schools are very similar in all of their features, and the private schools are closely related in their features. Outliers of private schools like BYU are really similar to public schools. LLE biplot resolve the outstanding features of those outliers. Outliers are still those top-ranked schools such as Harvard, Yale, Stanford, and Princeton. Let's look at the money use situation of each school. Most top-ranked private schools use their endowments well, while most public schools use their endowments poorly. Twitter data only has two categories in money used: fairly used and poorly used. Most public schools with a large PC2 value use their endowments fairly. In the Disney biplots, the two outliers of private school use money poorly. The money use situation of most outliers in the LLE biplot are well used. We can conclude that through PCA and SPCA analysis, we can know the characteristics of each point and compare points in the biplots. And Disney and LLE help us to identify the outlier clearly.